Alright, here we are back in the shop. Gonna modify this microwave oven transformer to create a high current, low voltage power supply. Not super low voltage, something like, 30 to 50 volts, something like that. But first we gotta chop the little bad boy apart. That's always a fun part. And so, I've never done this before, so we'll see how this works. Sure looked like we should be through the weld on that. Alright, let's try applying violence with a chisel and a hammer this time. Seems like this should be cut through far enough, but hey, there it goes. Looky there. Oh, okay, I get it. It was just the varnish holding it together. We were well past where the weld is. Okay, good to know. Like I say, never had one of these apart before, so this is all new to me. There's our primary winding. That's definitely the one we want to keep. And it's interesting, there's two secondary windings. This winding here is for providing power to the filament inside the magnetron. It puts out about 3.4 volts or so, and probably fairly high amperage, but like I say, it's not a high enough voltage for me to just use that winding. So now we got to get these windings out of here without screwing them up. I'm not really sure how I'm going to do that. I'm not really even sure if it's possible to do that. I really want to keep those intact though. It looks like there's a little bit of... Let's see if this will just pop loose. Ha ha ha! Not gonna happen. It's all glued together. However, there's a stack of laminations between the two coils, so I might be able to hammer. Hi, Natty. You're wondering what I'm doing. I'm cutting apart a microwave transformer. Isn't that fun? I might be able to drive a screwdriver in through those laminations and not hurt the windings. Let's see if it'll happen. I guess I could try and get that other winding out of there. Oh, that is in there pretty good, isn't it? What's up, baby? How's my cat? Yeah? Oh, I just fed you. I did, really. Oh, I hate this tripod. There she is. My supervisor. My supervisor's like, don't you have that apart yet? Come on, man. You're supposed to have this under control by now. Here's our little microwave oven transformer that we chopped apart in the last couple segments. And I've got the primary was at the top here. Well, whatever you want to call this end. I guess technically it would be the bottom. Either way, I moved it down to the bottom, what I'm calling the bottom, in the core. That way I can put in different secondary windings to make whatever voltage I want for whatever I'm screwing around with that day. Now, I've actually run this. When I previously ran this and I had all of the windings in it, such as here's the high voltage secondary, here's the low voltage secondary, which actually runs the filament in the magnetron on the microwave oven. And this is, before I tore this all apart, I put power to the transformer, and this secondary, this little one here that's only 4 turns, I think it gave me 6.4 volts. But then when I took this all apart and then I just ran it with the cap on, the other side of the core on there, then it only gave like 3.6 volts. So obviously I've made things less efficient by taking it all apart and taking out all the little packing and all that stuff. So I'm going to err on the side of creating too high of a voltage rather than too low of a voltage. So how I'm approximating that is, if we have 4 windings here and it's giving us 3.6 volts, divide that 3.6 volts divided by 4 windings, and I want 50 volts, just ratio and proportion that out. So we need about 55 turns. And we'll see if that actually comes out accurate, and the transformer might get more efficient when I put it all back together. And so that's what we're going to try for. So I whipped up this little pattern for wrapping my winding around. So hopefully I can get the windings off of this without totally unwinding them, basically. So that's what I'm shooting for. So now we're going to go put this in the lathe. I am probably not going to run the lathe under power because it's going to turn way too fast for me to wind this. For winding material, for motor magnet wire, this is wire that actually came out of a Chevy starter motor solenoid. And I pulled the solenoid apart years ago, and then I wound this solenoid for doing some other experiments. And so it's going to be our winding wire for this project. All right, after a little bit of fiddling around trying to get the wire through the hole on the pattern here, I think I'm just going to wind this by hand. Here we are back over at the bench. Here is the wrapped secondary for our microwave oven transformer modification. And I actually wound up rewrapping this. I didn't film it. I took off the plate and the wiring the coils kind of went sproing. And so I realized I needed some ways of holding those together while I took this apart. So anyway, this has been rewrapped. It came out a little sloppier than it did first time, but it should be fine. But what I did is I modified this form by putting it on the milling machine and milling a slot here and milling a slot here. And that means that I can theoretically slip a zip tie through those and pull it up nice and snug, which should keep everything together while I try and put it into the microwave oven transformer core. And so I haven't tried this yet, so you're going to get to see me either screw it up or succeed, as is usual with these videos. Let's see if this one wants to go through. There we go. This one's a little more complicated because the tails are coming out there. By tails, I mean the ends of the coil. Alright, so let's get this one zip tied down. I know I should be using Cape-on tape and all that happy cool stuff, but I don't actually have any Cape-on tape. And seeing as this is just an experiment, I don't really see any point in going and getting Cape-on tape. Boy, I sure wish I'd managed to catch that wire, that last winding under there. Did you guys see what I did there? That's okay. We'll do it like this, and it will be fine enough. And keep in mind, why we're doing this is I want a higher voltage, higher amperage power supply for the swamp cooler motor tabletop dyno machine, because my battery chargers, I've just got two 12-volt battery chargers wired in series is what I've been using, and that doesn't really provide quite enough power. And not only that, it maxes out the battery chargers to the point that their internal circuit breaker pops. And so in the interest of making it better, that's why we're doing this. Now, of course, I could have just gone and bought a transformer, but seeing as what I'm kind of doing with this channel is trying to build stuff as much as I can out of readily available junk that's laying around rather than going and buying new crap, I figured, let's try this. I've never done it before, so that makes it interesting. All right, so let's see if we can get this apart. I know we can get it apart. The trick is, can we get this winding off of here and get it onto the microwave oven transformer core without it falling apart? All right, now in that first part of the video I showed you how I had cut these pieces. Now you're going to see why that matters, because this doesn't want to come off of here. It's wrapped pretty tight. But what I can do is I can take loose parts of the core here. I really should have brought my drill out, but I don't have my drill, so we'll just do it like this. the old school way, back when mechanics had these big monstrous hands. I guess they still do. Actually, back when mechanics had arthritis by the time they're 40 from turning screwdrivers. All right, now see, this is gonna pop out, or at least it should, because it's cut at an angle. And there it goes. And see, seeing as that's cut at an angle like that, as I unscrew it, it comes up at an angle like that, which shrinks this way, which makes it pretty easy to get the coil off. Now, this block will also come off, but it turns out that it doesn't, that's not really necessary. I was probably overthinking it when I built it that way. All right, so now we've got to get our winding. Oh, come on, look, I get back in there. There you go. Yes, I talk to stuff. That's okay. My shrink says it's okay. Okay, so let's see if we can actually get this to go in there. I'm going to put the coil with its output out the other side. That'll make it easier to keep track of. I don't know if this is actually going to slip on there. Let's see if it will. Hey, look at that. God, that worked almost like I wanted it to work that way. How about that? Look at that. And yes, I know it should be epoxy potted and all that cool stuff. But hey, this is an experiment. It doesn't have to be perfect. All right, now the fun part is to see how much juice it puts out. I've got the other part of the core here, and in the interest of expediency, I'm just going to clamp this in the vise to hold this mess together. I'll come up with a more clever way of clamping it together later on, but for right now, let's clamp it in there and see what it puts out. All right, it's in the vise. I'll show you that in just a second, but I'm sure you can imagine it in the vise. Now, the way we figured out how many windings to make on this secondary is, remember this four-turn secondary coil that runs the filament in the magnetron? Well, when I put voltage to this, I actually got a couple different readings. Once I disassembled the microwave oven transformer core, I got about 3.6 volts, and this is 4 turns. So if we divide our 3.6 volts by our 4 turns, let me make this a little easier to see. If we divide our 3.6 volts by our 4 turns, we get about 0.9 volts per turn. So in this particular case, I wound up putting on 72 turns because that's how much wire I had. And I figured, well, if it's too much, I can always unwrap some rather than cutting it short and then going, oh gee, it doesn't make as much power as I wanted it to. So in the interest of just kind of playing it safe, I went ahead and put all 72 turns onto that secondary coil, the one that we just wound up. So if we take our 72 turns times our 0.9 volts per turn, that should give us approximately how much voltage this will put out. So we got 72 turns times 0.9 volts per turn means this should make roughly 65 volts. So let's hook it up and see what it actually does. But that's what we're kind of expecting here. Okay folks, here's our setup. Here's our victim, our rewound microwave oven transformer. Let me zoom out so you can see what I've got as a setup here. What I've got is a variac, but it's a low amperage variac. That's part of why we're doing this transformer project. So you got a low amperage variac. It's feeding the primary side of this microwave oven transformer. This voltmeter on the right is actually reading the voltage on the primary side. The voltmeter on the left is reading the volts coming out of the secondary side. Okay, let's zoom in so you can see the meters a little bit. All right, here we go. We're ramping up to 120 volts on the right-hand voltmeter. That's our primary side. Let's see, a little more. All right, there we go. 120. And look at that. We got 64. Okay. 64.7, 64.8 on our output side. So our little ratio proportion trick worked fantastically. It predicted the output of this like right on the friggin' money. So anyway, so I call this a success. And in our next video, we'll be putting this on the Swamp Cooler dyno, Swamp Cooler motor dyno. And then we're going to be dynoing, oddly enough, I'm going to dyno the Swamp Cooler motor that's actually in my Swamp Cooler on my house, so that we can figure out how much mechanical power that's putting out. And so that's going to be in the next video. But for this is, we're done. Thanks for your time. Thanks for watching. I hope you found it interesting. And we'll see you next time. Take care, everybody. Cheers.